Alright, today we're looking at solving advanced exponential and logarithmic equations. So we're going to start simple and then warm up the brain and see how far we can get. So let's say, example number 1, there we go. Let's say I have 8 raised to the x is equals to 2 to the x times 1 over 16. Well. First question, do you see a fraction? Yes, I do. And so I can write that fraction with a negative power. So that's 16 to the negative 1 times 16 to the negative 1. And then, all my bases the same? No, I can't. 8 is equals to 2 to the third power. And 16 is equals to 2 to the fourth power. So this becomes 2 to the third to the x is equals to 2 to the x times 2 to the 4 to the negative 1. Of course, these need to be multiplied. And so therefore this is 2 to the 3x is equals to 2 to the x times 2 to the negative 4. Now, unfortunately, I cannot cancel my bases just yet because I got 2 of these over there, so I have to combine them. And when we combine, we simply add the powers. And so this is 2 to the 3x is equals to 2 to the x minus 4 when I add those powers together. Now, finally, I can crush those 2s. So I can say, hello, Mr. 2. See you later. See you later. And so that leaves me with 3x is equals to x minus 4. And this is a 2-step process. Subtract x. Oop, I'm thinking 2-step. Subtract x, and so 2x is equals to negative 4, divide by 2, and so x is equals to negative 2. And lo and behold, we have an answer. Let's try one more example of this time. So let's say I have 9 raised to the x is equals to 3 to the x times the square root of 27. And I'm trying to solve this equation right here. Well, I see a radical. And so 9 to the x is equals to 3 to the x raised to the 27 to the 1/2 power. Remember, there's a hidden 2 right here and a hidden 1 right here, and the 2 goes below the 1, like so. And just like in the previous example, although my bases are not the same, 3 squared equals 9. 3 cubed is equals to 27, and so my equation becomes 3 squared raised to the x is equals to 3 to the x times 3 cubed raised to the 1/2 power. These simplify. 3 to the 2x is equals to 3 to the x times 3 to the 3/2 when I multiply 3 times a half. Again, I combine these. And so when I combine these right here, I get 3 raised to the 2x is equals to 3 raised to the x plus 3/2. Cancel. And now, hopefully I can get home from here with my good friend algebra. You know, me and algebra, we were walking down the road the other day and we just say, hey, what's up, yo? Yeah, you know. Me and algebra can hang anytime. Multiply by 2 to cancel the denominator, distribute the 2 across. That's 4x is equals to 2x plus 3. Subtract 2x from both sides. And so 2x is equals to 3. So x is equals to 3. There you go. Answer. Alright, so that's the first kind of equation where they have several types of variables and expressions floating about, and we got to get the common denominator, get rid of the fractions, get rid of the radicals, and then cancel bases in the end and solve. Sometimes, however, we cannot make the basis the same. So consider this right here, 2 raised to the x is equals to 3. Clearly, I cannot make this basis the same. So what am I supposed to do? Well, what I want to do is I want to solve for x, correct? And if I want to solve for x, it means I need to get rid of this too. I can use logarithms to get rid of that too. And so what I say, well, this is an exponent of base 2. And so what I do is I take log base 2 on both sides of the equation. See right here how I added in that log base 2 on both sides of the equation. It's the same equation. I just added in the same term. Technically, I took log base 2 on both sides. I didn't multiply my log base 2. That's a misconception. I'm taking the log on both sides. And then with this right here, I will have cancellation. This will simplify and just leave me with x is equal to log base 2 of 3. There you go. That's the answer to the problem. X is log base 2 of 3. Let's try another example where the bases are not the same. Let's say I have e raised to the x minus 7 is equals to 10. Again, remember, e is approximately 2.71828 blah blah blah. E is just here to hold that value 2.7 going on and so forth and so on. But clearly I cannot make my basis the same, right? Just like in the previous example, I have to take the right log on both sides to simplify. In this case right here, the log I will take is the natural log. So I have e to the x minus 7 is equals to the ln of 10. Then the ln and e will cancel out. It will do you a world of good to remember this fact. Ln and e are inverse functions, and so they will always cancel each other out. And so that leaves me with x minus 7 is equals to ln of 10. And of course I just add 7 to both sides. And so I have that x is equals to ln of 10 plus 7. Again, the ln 10 and 7, they don't add together because this ln is going to be a decimal. If you look it up on your fancy graphing calculator, you see that that's a decimal, and then you add 7 to that decimal. But since we don't really care that much about calculators, we can just leave it this way and call it a day. Yeah, so it's just ln 10 plus 7. Again, more of these canceling questions. What happens if you have an expression like this? 5 times 2 raised to the 5x minus 3 is equals to 25. And I gotta get to this x way up there. How can I possibly get to that x? Well, what you don't do is multiply these things together. That is illegal. And that is because PEMDAS says I have to consider the power first. And because of that, I cannot, let me say it again, cannot multiply the 5 times the 2 and make it 10. So instead, what I'm going to do is I'm going to get rid of the 5 by dividing both sides by 5. You have to get rid of that coefficient first. And so I have 2 raised to the 5x minus 3 is equals to 5. Now, I can get rid of the 2. The way I will do that will be take log base 2 on both sides. Again, I am choosing my log based upon this base. If this was a 7, I would take log base 7. If this was a 9, I would take log base 9. But it ain't, but it isn't. And so I take log base 2 of 2 raised to the 5x minus 3 of 5, and of course they're equal to each other. Again, this I am not multiplying the log, I'm taking the log base 2 on both sides. These cancel, so I have 5x minus 3 is equals to log base 2 of 5. 2 steps remain. Add 3, then divide by 5. So I'm going to add 3 to both sides. 5x is equals to log base 2 of 5 plus 3, divide by 5, divide by 5, x is equals to log base 2 of 5 plus 3 divided by 5. There you go. That's an answer. That's a wrap. Alright, so that's the second category of advanced equations. One, when the bases are not the same, and you have to choose the correct log to simplify everything to take you home. The next kind of log equation is a log equation of quadratic form. Let's say I have right here 4 raised to the 2x minus 2 times 4 to the x minus 24 is equals to 0, and I'm saying to myself, self, how do I solve this problem? Well, these are not like terms. I can't add them together. Well, the trick right here is the number 2. The trick right here is the fact that there is a 2 right there. And what I can do is I can factor that 2 out. I can write this problem right here as 4 raised to the x squared minus 2 times 4 to the x minus 24 is equal to 0. If I asked you to simplify this back in the day, you would just multiply these two together and give us 2x, correct? So I'm undoing the simplification. So you're saying to yourself, well, why? Why? Well, the answer is I can then replace this 4x with a letter. I can say that this is n squared minus 2 times n minus 24 is equal to 0. I'm going to let the letter n represent 4 to the x. And by that representation, I now have a simple quadratic equation that can be factored and be solved. This factors into n minus 6 and multiplied by n plus 4 equals 0. And so that will give me n equals 6 and n equals negative 4. With that right here, I can then go back and then solve this equation. Well, the letter n is representing 4 to the x. So this first piece right here actually means 4 to the x is equals to 6. Well, this is one of these questions we just did a while ago. I cannot make the basis the same to solve, and so I will just take the appropriate log base 4 on both sides of the equation. And I'll have that 4 to the x is equals to 6. And then I have my cancellation, so x equals log base 4 of 6. Look at that. Magic. On the other hand, on the other side, over here, I have 4 to the x is equals to negative 4. Take log base 4 on both sides. Log base 4 of log base 4. And I have my 4 to the x is equals to negative 4. These cancel. X equals log base 4 of negative 4. But, we then recall that this does not make sense. You cannot take the log of a negative number. This is undefined. We say, oh no. And so that tells us that we actually only have one answer. And that one answer right here is log base 4 of 6. This right here is an extraneous solution. A solution with no friends. It's really sad but true. Let's try one more of these questions. Let's say I have 9 raised to the x power minus 6 times 3 to the x power minus 7 is equals to 0. Again, I don't have like bases. So what am I supposed to do right here? Well, I can make the bases the same. 9 is equals to 3 squared. And so then this is going to be 3 raised to the 2x minus 6 times 3 to the x minus 7 is equals to 0. Now my bases are the same. Then I do that same trick I did a while ago. I rewrite this as 3 to the x squared minus 6 times 3 to the x minus 7 is equals to 0. And now I can solve this problem. Call this n n minus 7 is equal to 0. This factors into n n minus 7, n plus 1. And so I get that n is equals to 7 and n is equals to negative 1. But I know that really and truly n is 3 to the x. 3 to the x is equal to 7. 3 to the x is equal to negative 1. I can immediately strike this answer from the previous example. We know that this will not give us an answer, so I can just toss it. And on the other side right here, I take log base 3 on both sides. And so I get that x is equals to log base 3 of 7. Okay? When we come back, we will look at our log equations and how you solve those.